Everybody, first talk this morning, which will be given by Valeria de Paiva. Then I was a PhD student on my first PSSL in Cambridge. I met Valeria, and we were both more or less the same generation. We both studied Toelstra's book on all kinds of proof theoretic interpretations. In those days, the craze was linear matching, and that was the first, I think, motivation for doing Dialectica. And then later there were other developments, Martin Heidel's paper. We had a group with Pino, Martin, Thomas, Esther Boots, Lars Birkendaal, and that resulted in the PhD thesis of Boyle Beering. Then Peter Hofstad Institute, Valeria, and her group did a very nice thing.
Thank you, thanks very much. And it's a great pleasure to be here. And I mean, I know everyone had a good night last night in the dinner, so this is going to be an easy talk, fluffy talk, with lots of pictures. That's why, I mean, don't get worried about the numbers there. So, well, that's the normal way, right? With thanks. So, many thanks to Nikki for organizing this beautiful workshop. He did all my stuff. And, I mean, they're coming. Things to say about them too. And thanks, David, for the invitation to discuss this kind of work. So, and thanks, David and Matteo, for all the work. And then I'm kind of doing the usual stuff that one does of kind of telling you what I'm going to tell you, then I'll tell you what I want to tell you, and then I'll tell you what I just told you, okay? So I'm going to be very high level on the presentation, but anyone who wants to know about it can go and look at the papers, which are also in the archive, so everyone can read about it. And I thought I was going to start with some personal stories very quickly, but I wanted to talk about the fact that I have two careers in research. Yes. One in more mathematical stuff, and that has this illustrious lineage, because this is Martin Hyland, who was my supervisor in Cambridge, and that's Robin Gunn, who was his supervisor, and this one I hope you guys know, Alan Turing. And you know, this is kind of special because Alan Turing only had one student, which was Robin Gunn. So kind of beyond that many of us that are, I mean, I'm his great-granddaughter academically, right? And the reason I'm putting this, I think that's a very nice quote from Martin Hyland on the idea of categorical proof theory, and that is from the Proof Theory in the Abstract in 2004, which was a volume for Professor Trusler. And the reason I'm putting it here is because I think, you know, not only we have to pay homage to our four founders in category theory, like Bill, which it was such a great honor to honor in this conference, and all the others like MacLean and Kelly and everyone else, and Martin Hyland and Peter Johnson and Thomas Stryker and Bill Mussolini. I mean, sorry Thomas, we are getting that old, so you know, we're getting to be four founders. But I also kind of wanted to say that we also owe a debt, an intellectual debt, to the philosophers. In this case, I'm actually talking to Giovanni Zambin and also to Pearl Martin Leff and Dad Kravitz, because, you know, they always remind us of this business that we do calculations, and calculations can have the merit of simplicity. And I've seen beautiful talks in this conference on what simplicity takes the day, and you have, I mean, simplicity in a very contorted way that only category theorists can appreciate. But you know, the thing is, there is an important thing about philosophical weight, and this cannot always be guaranteed. In the end, you cannot state the need to form a judgment of significance. So we have to pay attention to this for founders too. Okay, enough of that. I know, one more thing. The reason why this is such a light talk is such a fluffy talk, and Thomas will hate me because of that. It's because I am I spent the last 24 years in Silicon Valley kind of working for tech companies. And I'm now trying to go back to academia, but in a different way. Academia kind of being a startup company that doesn't intend to kind of make lots of money, but intends to sell, in quotes, mathematics to everyone else. And that's the Topos Institute, and that's our motto, our vision. And I think it's very important and very good. And of course, the judge is still out of whether we'll get there or not. So we're trying. Okay. Still one more thing to say about generic things, which is that I kind of intend this to be a bit like a Netflix series, and it has 3 bits. So it starts in the 1940s, kind of early 1940s with Kurt Gödel. Then it goes to the 90s, early 90s. Jack was asking exactly when my thesis was. So that's about categorical dialectica, using categories in the early 90s and having to do with union logic. And then we end up with dialectica using doctrines in the 2020s after the pandemic. So these are the 3 things on top, and if I'm kind of getting too slow, feel free to hurry me up. Yeah. Oh, sorry, that was a bit too much. I said this story starts in the 40s, but everyone knows that actually Gödel published his interpretation in 1958 in the special issue of the journal, the Swiss journal Dialectica. And what he said he was doing was an interpretation of intuitionistic arithmetic, HA, in a quantifier-free theory of functions of finite type, which became known as System T, and people call it System T to this day. And the main idea of the dialectical interpretation is that you want to translate every formula A of Haitian arithmetic to a formula of this shape, where you start with an existential, and then you have a universal, and then you have a quantifier-free formula. And this is kind of very good because you then can prove, you can say that if Haitian arithmetic proves a formula A, then system T, which has no quantifiers whatsoever, but has functions of finite type, and the functions of finite type the types are going to get bigger and bigger and bigger quickly. But so you're trying to do what people call nowadays a liberalized version of Hilbert's programs. So you're trying to make things that are very complicated, simplified, because you don't have quantifiers anymore. But on the other hand, you're trading this off for types that are every time more complicated. You start with the natural numbers, you do functions of natural numbers into natural numbers, and blah, 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 and getting bigger types. And one of the things, I'm not an expert on the 1940s by no means. The only thing I wanted to mention here is that the things that I'm going to say I always learn them from, as Jaap was saying, from Professor Trooster in Amsterdam. And so all the stuff that I'm saying here you can read in the translation and the commentary that Trooster did of Gödel's collected works. And one of the things that Trooster says is exactly that the goal of Gödel was to be as constructive as possible while being able to do the whole of classical piano arithmetic. And the idea here is the usual one, that you're going to do the work for Haitian arithmetic, but then you get into piano arithmetic by doing a double negation translation on top of what you have. And so that was the goal, and this is what the dialectica looks like, and it's very traditional in some ways. You have conjunctions behaving like conjunctions, disjunctions behaving like co-products, right? You kind of have a zero and you go to the first component, and different from zero and you go to the second. And the trick, and Professor Gödel was known for his tricks. The important trick here is what you do with the implication. And it's here that the functions start playing a serious role. And there are very different sorts of roles that the going up in the hierarchy of types is going to do for you. So his theorem, just for completeness, is kind of written here, right? Whenever formula A is provable in Heinz arithmetic, then there exists a sequence of closed terms T such that the quantified thing is provable in system T, and the sequence of terms and the proof itself are constructed from the given proof of A in the original system. So, so now we get into the important bit, right? The complicated clause of the translation is the definition of the translation of implication. And what we have to have are these two functions, little f that goes from u to v, and capital F that takes a mu and a y in the consequent and brings things back to the antecedent. And one intuition that you can have for this script is this idea that, like lots of other functional interpretations that came after the Dialectica, you always have this idea that if you're going to interpret an implication, you have a witness for the antecedent, and you have a construction that transforms this witness for the antecedent into a witness for the consequent. And so the first bit, that you have a witness u for the hypothesis, and then a letter f that assigns a witness f of u to the consequent. It's all traditional. But the important thing from the other, the kind of the tricky thing, the kind of more interesting thing, is that from a counterexample y of the conclusion b, you should be able to find a counterexample for the hypothesis AD. So in a way, you are proving things in one direction and finding counterexamples for them on the other direction. And this is what makes the Dialectica such a, as Thomas was putting it the other day, a mysterious and interesting interpretation. Okay, and again, read it in Pfefferman and everyone else. And feel free to ask questions or to disagree. I mean, as I say, I'm not an expert on that, but that's how I see it, and it's all coming from Tristram. Now, the other thing that Tristram says is that you can try to find motivations for this functionals that we are going to use to explain the implication by a series of transformations that were given by Spectrum in 1962. And I can certainly not go over this for the time being. You guys have to go and read it. But one important point here is that 1 and 3 are intuitionistically valid, but 2 requires the independence of premise that we had discussed on the first day of the conference. And number 4 requires a version of Markov's principle. And 5 requires 2 uses of the axiom of choice, or the rule of choice, I think is the way that Millie calls it. And so these are the principles involved in the translation, and they are not intuitionistically valid. They kind of get you out of the intuitionistic realm. So, and we're going to see them again in a minute. So let's just move on. So that was happening in the 40s, right? This version of, Gödel trying to not be so nasty to Hilbert and trying to find a version of the Hilbert program that would make sense, even if it's slightly different from what it was originally meant. Now, in the late 80s or early 90s, Martin Hyland came and said, oh, why don't we do an internal version of the Dialectica? And I kind of didn't understand at all what he was talking about, but he was very kind and he said, well, just think about things like that. I give you a category C. It has pullbacks, at least, and we'll see what else we need on that. And then think about having, so you have C, so give yourself a little bit more elbow room, give you finite limits, because they need pullbacks for a certain, having products is useful. So So let's build a category, dialectical of C, whose objects are triples, where U and X are objects of the category C, and alpha is a subobject of the product, U times X. And think of this object as representing a formula of the dialectica. So, we're not paying attention to the quantifiers that much. We are paying attention to the fact that there is a side of the world that's trying to prove things, a side of the world that's trying to build a counter-model or a counter-example. And, these two sides of the world have to interact in some way. And then, forget about what we discussed in the first season of the Netflix series. We're now in the second season, so we only have category theory around. We're not thinking about the reasons why we're doing that. But anyone who's done a little bit of category theory can say, okay, I'm going to have objects that are triples like that, and I'm going to have maps that are pairs of maps of the category C. One map goes from the first component here to another component, because if I have an existent U for OX, alpha of UX, I will have another one which is existent V for all Y, beta of VY. And let's think about maps with this shape. And because we are thinking of categorical, we're thinking of logic in general, so let's subject them to the entailment condition as such. So this, you can play with that just as a construction in category theory. And you can then go ahead and try to prove things like, oh, is there a product in this category? Is there an internal home in this category? Co-product? What can we do? And that's what I did. I just went calculating stuff, as a good first-year PhD student does, right? And that's kind of ended up being my thesis, because I had a bit of a problem, because Martin said, well, try to calculate this, because we should end up in a Cartesian closed category, because we are thinking that it should be something related to intuitionistic logic, and so it should end up in a Cartesian closed category. And I couldn't, as much as I tried, I couldn't make this thing be a Cartesian closed category. So I kind of came back very fearful to Martin and said, look, Martin, sorry, but the maximum I can do for you is a symmetric monoidal closed category. I cannot. The thing that it seems obviously as a product here, the thing which you just take the U's and the V's together and the X's and the Y's together and put the obvious relation on them, does not give you a proper product. It's only a tensor. And instead of being cross and saying, oh, go back and try to do that and stuff, he just said, oh, that's, I was going to say, he says, that's cool, but he didn't, because that's not the word that Martin used. But I think he said, that's interesting. And I heard something about France, where people are doing this kind of stuff. And I think maybe that's what we have here, is an example on in real life example of a system, of a model, a categorical model of a system of linear logic that someone called Girard is discussing at that stage in the 1990s in France. So I ended up presenting this stuff in Boulder, and kind of when I showed Girard the category DIOC as a model of intuitionistic linear logic without bands, and then how to construct bands which are extremely well behaved, he said, oh, I can do better than that. And then gave me another construction that I'm calling Girard C, which is a simpler version of a dialectical category. Well, simpler in the sense that the morphisms are simpler, but you have to pay a price, and the tensor is much more complicated, and the way to go back to the normal world that's not linear, that is intuitionistic or classical, is much more complicated. And today we're only talking about the first half, so we only talk about the real dialectical category, not the Girard category. And you might ask, why is this interesting so many years later? And as I said, I have that many slides because lots of them are just pictures. And it is interesting because because some of us believe in this idea of carry-out correspondences all over the place. And that's the traditional one, which has our friend Bill, as on the side of the category theory, privates on the side of logic, and church on the side of, I'm losing my point, I'm sorry, on the side of the lambda calculus. And hence, what I had at that stage was a different model. I mean, the model that I just showed you, this triangle that Bob Harper nowadays calls Trinitarianism, or you know, something a bit like theological things. There's a Holy Trinity, and so Bob calls it Trinitarianism. So this is the traditional example of Trinitarianism, which is the simple type lambda calculus, Cartesian closed categories in intuitionistic propositional logic. We tend to think of it as being syntactic, right? We discussed the free category over intuitionistic propositional logic, over the fragment of intuitionistic propositional logic, which has just the implication and the conjunction. But what kind of we came up with, this original dialectical categories, is a construction that exists in mathematics as such, and it satisfies the same sort of triangle. And what the stuff that Girard kind of suggested is another one of these where we now do the classical linear logic, and or actually what I end up calling full intuitionistic linear logic. That's Martin Hyland again, because that's what Girard was most interested in, and that's what I was very interested in at that stage. Now, I'm not going to read this whole thing because I think everyone here knows that the difficulties of modeling linear logic are the fact that when we're doing things Cartesianly, we are very used to having products in internal in function spaces, and we kind of needed to make that all linear. And the category theorists knew all about that much earlier than that. So they knew it in the 60s. Kelly and Laplace in the 60s already knew how to make a real product, a tensor product. So the problem that I had, and that everyone else had at that stage, was that we needed to get the modality to bring things that were linear back to the intuitionistic world. And so modeling, creating a model that dealt with this, I mean, a clash of conventions here, because Girard calls the bang and the of course exponentials. But for category theories, exponentials are function space. So you've got to be careful not to confuse the two terminologies in the same sentence. So what was hard for me and for everyone else who was thinking about that, and lots of people since then, was to think how to deal with the bang. So how to define the operator that makes everything usual, makes everything go back to logic as we know it. And we end up in this situation that the dialectic category is a symmetric monoidal closed structure, and has products and only weak co-products, and we are getting bad, and makes it a model of exponential-free linear logic. So finally, I mean, I have some intuitions, just one bit of intuition here, that, apart from thinking about the left side of the world, the existential side of the world as being proofs, and the right-hand side of the world, the bit about universal quantifiers being counter models and counter examples, another intuition that you can have is that, and that was pushed by Andreas Glass, was that the U's can be thought of instances of problems, whereas the X's can be thought of as solutions to the problems, and the alpha just as this is a correct solution for this problem. And that sort of intuition is very fruitful. Lots of people have been thinking lots about games on that. And I kind of used to call them superpower games, but I haven't done much with them. So I'm not going to give you examples. There are it's easy, and you have the slides later on and you can check. And I could do some more propaganda here, but I'm going to skip it up. And then I'm getting to things that are a little bit more contemporaneous. So the model that I described from the early 90s is pretty cool. There's lots of very recent work in applications of this model to different areas of not only computer science, but also mathematics. So there's applications in set theory and cardinalities of the continuum, and as well as things that are more computer science. And then people started generalizing it, of course. So there are several different versions of generalizing the construction to arbitrary vibrations. The first one in that paper that I mentioned by Ireland, then Bojubiri wrote her thesis with Lars Bickendal on generalizing into vibrations, and then Peter Hofstra in 2011 came up with this very interesting paper that is going to come up in a minute again about the dialectical monad and its cousins, so now we get into the third season of the saga. We get into the dialectica via doctrines, because David had this idea that he wrote to me asking about the weak co-products, saying, well, why weak co-products? Can we do better than that? And we kind of started thinking, he started thinking, and we now have this version of this categorical version of dialectica in terms of Lovier's doctrines. And you might ask, why do that? Isn't that modeling the categories enough? And there are several reasons why it's not enough. But I think the only one first one, the obvious one, is that everything that I was thinking about was only propositional, and now we want to deal with the quantifiers. The first order quantifiers will give you more expressive power, and you might need this extra expressivity. But the point of the papers that I mentioned at the beginning is actually that you also get a much tighter correspondence, much tighter correspondence between the logic and the category theory, using the doctrines. And in particular, you get the ability to show that not only the internalization of the morphisms work, but actually that every formula can be transformed into a formula of the shape that we wanted, the shape that exists in U for all x, a quantifier free. And so that's what I'm kind of hoping to do now, if I can. Yes. You're paying attention to the time, right?
You're doing fine.
Good. So, so the way David kind of, and Matteo kind of wanted to talk to me about that is a little bit funny, because, they say things like, Valeria, we need a more modern version of the construction. We need a version that is not, that's kind of categorically modern, meaning where we can see what are the universal properties. And then I feel even more old than I normally do, right? How to have modern category theory. But, it does make sense to say that if we want to capture the essential ingredients of the interpretation using doctrines, then we want to be able to say that given a doctrine, is there another doctrine such that the dialectical doctrine over the second one is isomorphic to the first one? And if such a doctrine P prime exists, how do we find it? So we have answers to that now. So we say that P prime exists precisely when P is a Gödel doctrine, which I'm going to define in a minute. And we say that that P prime is given by the quantifier-free elements of the Gödel doctrine P. And the notion of quantifier-free elements seems to me a very exciting development, because as we are discussing, we've had since the 60s, we have had the idea that the way to deal with quantification, the Levy way of dealing with quantification, which is left adjoints and right adjoints, to the pre-index factor, you know, that means we know how to model quantification, but I don't know very much how to, I did not know until we kind of had this stuff, how to model predicates that are quantifier free. And that's what we end up getting here. Right. So, moreover, the important thing that we actually can prove to you in the papers is that the classical principles that dialectica satisfies, the independence of premise, the Markov principle, and the absolute choice can be seen now in the categorical modeling, which is something else that Miri kept telling me in the early 2000s, that, you know, we want categorical modeling that actually is done through internal language, so that everything that happens in the logic happens in the category theory, and vice versa. Things that happen in category theory can pull back to the logic. And and that does give us a more conceptual modeling in terms of universal properties. Okay, so that definition has happened in every single talk in this conference, so I'm not going to go over it. But, you know, my version, some of them didn't have finite products in C, some had. Mine does have finite products, and you go, the doctrine is just a functor, and you go to category process. And here I start getting a little bit hazy. I know that doctrines that are existential, respectively universal, are the doctrines where for every projection you have your left adjoint or respectively your right adjoint, and they satisfy the back-Chadley conditions. And I'm saying that I'm getting a bit hazy because sometimes I wonder, sometimes I think the Frobenius conditions have to be there and sometimes they are not, so I get a little bit, I know you guys know, but I get a little confused. And then I kind of, David told me about his PhD, where he came up with the existential completion, so showing that not only it satisfies, but it also, not only it exists, but it also satisfies all two categorical properties that anyone wants, or something like that. I'm exaggerating, don't worry. But due to kind of not everything, I don't think anyone has written that all the full details, there's a preprint, but that you can do the universal completion, and I don't think anyone has proved all the details about that, but it's at least the way we need to use it for this work, it follows in the wash. It's just do the dualization and everything works. And so here is my most complicated slide, because we want, as I was saying, we want a suitable universal property to represent predicates that are quantifier-free categorically. And we will have already dual definitions for existential and unifier quantifiers. We will have, not we had, we will have. And the way that is done in that paper is through a three-step process. First thing that you do is to define existential splitting predicates. And I'm told, and again, correct me if I'm wrong, but that it is something that appears in Mayex and Proctor, that just appeared, but it existed before, and appears in Jonas Ray a bit earlier. I don't know exactly how, but I know that this idea that you want to say when a predicate is existential free, then you actually use a splitting of the morphisms that goes into something that in the internal language you would read as an existential beta, and you kind of say, okay, I do first the instantiation of some, when I split this morphism, I get a G that does an instantiation and something else. And so this idea of existential splitting predicates will allow you to create existential free predicates, which are the existential, are the predicates that satisfy the existential splitting but are also stable under pre-indexing. And that makes sense for me as a logician, because reindexing is just kind of doing substitutions, and if something has no existentials, then substitute and it carries on not having existentials. But then you also have to come up with this other notion that doctrines that have enough existential free predicates as well as truths. So this is the hard bit, and you have to go and read carefully in the paper. But But then, in the traditional style of category theory, you kind of put all the ingredients together, and now instead of a Netflix series, you have a recipe show. So you put all the ingredients together, and you invent a notion of a Gödel doctrine. And for this notion of a Gödel doctrine, you need that your doctrine, that the original category of the doctrine is Cartesian closed, that the doctrine P is existential and universal, that you have enough existential free predicates, and another one of the complicated ones about existential free objects of P being stable under universal quantification. And some final one that's this, oops, sorry. I knew I was going to go too much. So we invent this notion of a Gödel doctrine, and it is a mouthful, as everyone can see. And without the last item, we call it a Scorum doctrine. And here's the interesting so it's interesting and slightly poignant because actually Hofstra in 2011 was already thinking along these lines, and in that paper that I mentioned, he kind of came up with this idea of a Dialectica doctrine, which is a direct generalization, which our version of dialectical vibration is a version of his stuff. So let me recap. Our version of a dialectic doctrine is exactly is a direct adaptation to the proof irrelevant setting of Hofstra's definition of a dialectical vibration. I'm not there. Eventually I get there. And so he had, and I thought, since it was complained that we didn't have a picture of him, a picture of Hofstra, because in 2011 he proved that in a more generic case, the case of the vibrations, he proved that there is an isomorphism between the dialectical vibration and the completion under universals and then existentials that is isomorphic here, the equivalent. And we have a version, a similar thing, except that we now can do what I mentioned at the beginning, that you can say when the B exists and stuff like that. So we have this version that every Gödel doctrine is equivalent to the dialectical completion of the full subdoctrine P prime of P consisting of the quantified free predicates of P. So then you just, you make the cake, you put the ingredients together, and then you get all the terms that you wanted to have. So the first term is the one that I mentioned before, that every object can be, of this Gödel doctrine can be put in this shape. So in a Gödel doctrine, every formula admits the presentation of the exact form used in the dialecticum. The morphisms are the dialectical categories that, if you remember, I had to say to you, think of that as being a formula, and think of this as being the functions that we see inside the interpretation. But I was appealing to your analogies, but now we can have a real stuff. And its colonization in dialectica is more, you need to do. Again, you have to do hyper doctrines now because you want to have the whole hiding structure, not just the morphisms and the objects. So these three are kind of justifying what I was doing in the 90s, using the internal language as we wanted. And then, as a cherry on the cake, a cherry on the top, you get that every Gödel hyperdoctrine satisfies the rule of independent supremacy, and the Gödel doctrine satisfies the modified Markov rule that we need. And Matteo and David also kind of want to not to have rooms to have the real principles, because they think it's nicer. So there's another theorem along these things that I'm not going to discuss. So summarizing, what did we do in this 30 minutes? We, in the last 10 minutes of the 30 minutes, we used existential and universal doctrines and their completions to provide notions of quantified-free formula for the modeling of the dialectica, and we showed that the Gödel doctrines that we invented exactly for that satisfy the dialectical normal form in scale codes. We showed soundness of the implication of the dialectica, which everyone knows is the trick, is the hack of Mr. Gödel. We kind of shown that discolonization, dependence of premise, and Markov principle obtained. And so we have a very faithful categorical description of the dialectical interpretation, another 30 years after the first categorical version. So the original models have several applications: games, set theory, functional imperative programming, concurrency, automated theory. So the doctrinal ones should have applications too. And we are working ourselves in a generalized proof relevant version with Jonathan Weinberger. And I will stop right now. Thank you.
Thank you very much. Valeria has left some time for questions. Go on.
I'm very glad I was here because usually you understand things only when you find a way to connect to what you have been doing. So I found that. And I offer it to you as a possibility of future work. When you mentioned the interpretation by class, you said that you have a set of problems, a set of solutions, and a subset alpha of the Cartesian product, which means a relation between the two. That I call a basic pair. And seems silly, but actually it brings to a lot of structures that was not seen before. If you take the category BE for basic picture as the Frey Grandis completion of right square, then you have an environment to do topology without miss, namely without being Cartesian closed. So that's also very interesting. And you find a lot of structures which were not seen before, like duality between interior. Oh, I forgot. In a basic pair, you have a topology because the dynamics between the two sets
Are you going to develop a whole theory?
Okay, right. Thank you.
Question section.
Very good. Thank you for reminding me that. I am always taken by enthusiasm. Anyway, so it looks very interesting to investigate how you can use first.
Thank you. I mean, I'm sure. I mean, I have known lots of other applications, other interpretations of this framework. I didn't talk at all, but Matteo Capucci, who's just down there, kind of also knows about some of the applications on functional programming. All this work on lenses has to do again with the stuff that we're discussing here. And so, there are lots of variations. I don't know all of them.
Millie has a question.
Valeria, I want to put down that I know that with the development done by you, Davide, and Matteo, you get models for Dialectica with the epsilon, invert epsilon, and the new, the dualization of the epsilon with the mu. Were they new before for that or not?
I do not know. And I don't think it's total. I mean, David has stuff in his head that he has not put into paper completely yet, right? Or, I mean, some of it is already written in the paper with me.
Yeah.
Now,
Yeah,
we have
that's
there was a connection with that, Hilbert Epsilon, but I was making a comment that through your work, you can, so through your work, this analysis, of logic analysis through doctrines, there is, as a corollary, you get models for dialectica that comes from anti-arithmetics with epsilon and tau, which is not completely institutionalistic because it has some classical things. I want
But
to
it's
know
kind of very
if
interesting,
it's
yeah.
known, this, you know? No. Okay, thank you very much.
Really, I think that's a good thing that you mentioned.
In a further application that you bring to the space, since it's a problem to find modes, extra modes, so syntactic or later, like in toposes, with epsilon and mu. Tau, sorry. Good. It was also related to the word by Fabio. Yes, thank you very much. Sorry.
Yeah.
Could you give a bit more intuition for what's going on with the quantifier-free predicates? Like, can you recover quantifier elimination using this framework?
Well, you should say that. That's exactly what Ben was asking me. You know, like he wanted to say. I mean, I was saying, okay, we want to know when a predicate is quantifier-free. That's important for us. And he was saying, and then can you tell me when you can do quantifier elimination? I can't at the moment, but I think these ideas here will help on that problem.
It's a very classical thing, right?
Yeah, exactly.
Quantifier elimination.
Not
Yeah, I don't know. It's short answer.
We can discuss it.
More questions? Thomas.
I read quantifier-free part of a hyperdoctrine. Maybe you defined it, but I did not get it. Is it axiomatically given or?
No, I mean.
No, it's,
no, we're just looking at a specific doctrine that has this probability, this possibility of being where the predicates are considered quantifier-free, right? I mean,
but that's a syntactic notion. How can you semantically say that something is quantifier?
and that's the notion of existential splitting that the guys came up with.
but that's
And, you
the,
know,
I think that's actually the achievement.
yeah.
The achievement is to define this notion of quantifier free, and then they get what we never achieved when we study dialectica. You can look at the categorical model of dialectica, but then you ask yourself, why is this a model of dialectica? Because it shares some formal properties. But this,
I think Jonas has something to say about that too.
So I think what you call quantifier free, that's actually not characterized quantifier free formulas in a syntactic doctrine, and that's why I call them exists prime, because they are like the joint prime elements in a
yeah, but I can say something that this is a right notion for the case of existential completion, so it matches with the logic, but it is a semantic notion, and you cannot define the free because it is a semantic notion. Okay. Let's discuss later. This
I mean, that's a very interesting discussion, which I also want to understand better.
which we relegate to the coffee break.
Yes.
So let's